If you could go anywhere on the moon, where would you choose? Imagine that. This vast expanse of land is riddled with nitrogen pits. Dusty. It's not just mountains and craters, and the wonders of science and the secrets hidden in the dark shadows. However, in the absence of a proper map, it's easy to miss some of the highlights of our closest celestial neighbor. Fortunately, in the past 15 years, the Lunar Reconnaissance Orbiter has been making maps like this. He recorded the features of the lunar landforms as never before in Kyoto, helping scientists gain a deeper understanding of the moon's changing surface and the control processes behind it. Through more than 8 billion unique measurements, its detailed analysis makes the moon the most accurately measured celestial body in the solar system outside of Earth. To give us the tools our future might need to build a permanent base on it. So what did he find? We'll take a look at some of the most fascinating discoveries and landmarks he's captured on his mission to date. Since 2009, the Lunar Reconnaissance Orbiter has been scanning the lunar surface. Equipped with a powerful camera, capable of taking high-definition photos and send them back to NASA's planetary data system. He can send up to 105G of data per day. 5 or 5 coins are withdrawn every year. For comparison, it took the new Lunar rover exactly 2 years to complete the data transmission of a flyby of Hades. Although the Lunar Reconnaissance Orbiter has been launched for more than a decade, but he's still running. With its high-performance cameras and topographic mapping capabilities, we are constantly learning new information about the lunar surface. Let's see how this camera works. So let's start with a very high-contrast environment. Start Jackson Dolomite Crater. Unfortunately, since he is located on the far side of the moon, we don't have an oblique view of this crater from Earth. It's a little bit like Imperial Crater on the side of the lunar mirror. When it formed, it produced a radiation system that stretched over kilometers of the epidemic. When particularly fine material is ejected far from the rim of the crater, such a radiation system is formed, although its specific formation mechanism is still being studied. Jackson Crater itself is about 70 kilometers in diameter. Its scale is huge, accessible from its stepped edges and the raised edges of the central region. Normally, this cloudstone crater is actually inclined. The eastern edge is 6 kilometers above sea level, and the west side is only 3 kilometers high. The base of the crater is 1 kilometer above sea level, and the central wind is pushed up by material from higher up. Some dark spots can be seen along the pit wall. This is the shadow caused by the angle of the sun in the sky. In sharp contrast to the mainly light-colored ground, but the scene here is not as relaxed as you might imagine. Your perspective and that of the sun are crucial for observing the contrast between the lunar surface, especially when focusing on the central wind in the image. Now we switch to an overhead view of the same mountain taken at a different lunar time. All of a sudden, the entire Yunshikeng Basin floor and the tip of the mountain. Written more than before, dim many orders. Combine 2 pictures, side-by-side comparison. It does reveal a huge difference in contrast. This is just one of the many examples of the moon visually deceiving you. Take a closer look at this picture. What do you think it represents? These areas are inverted cheongsam. Or is it actually higher than the warped texture of the surrounding material? For a long time, I can only see it as an inverted form. But maybe when you look around the whole image, your perspective will suddenly change. What type of image did you initially notice? Do you need to prove, as I do, that he did not actually cause? Trying to see the same area from different angles can help you get the right perspective. This visual transformation amazed me at how I could see another scene. This is a small region on the moon called Ina. It's only about 2 to 3 kilometers wide. The depth is 64 meters. So far, no one knows for sure how this unique terrain was formed. Ina is the most prominent of several similar regions on the moon. To a certain extent, similar optical illusions also appear in small craters. Did you see a dome or a crater? Sometimes rotating a picture can help you get the right perspective. And that's exactly why the Lunar Reconnaissance Orbiter seems to me to be extremely useful. We can not only get top-down attempts. You get a slanted view. Let's turn now to another unusual region of the moon. Explore Komarov and the rock pit. If it weren't for the huge fracture line at the bottom, this crater is fairly ordinary by lunar standards. Komarov crater is 95 kilometers in diameter. This means that the depth of these cracks can reach 500 meters. The width can reach 2.5 kilometers, presumably about 260 billion years ago. Magma accumulates under the crater, generated tremendous pressure that caused the Earth to break apart. Although it appears that the magma never reached the surface, this means that these cracks have never been filled. It's been that way ever since I was a kid, although it didn't happen this time. But there is a phenomenon on the moon where magma does break through the surface and converge. One such example is the one on the west side of Plato crater. This is a massive crater 100 kilometers in diameter, located in the northern part of the moon. Even with a telescope or binoculars on Earth, this picture shows some pretty spectacular scenery. The most conspicuous of these are cracks running through the ground. This part of the area is a lava vent. Reflects the activity of past lunar addresses. Flowing southwest from the lava mouth is a landform known as Lima or Hegwo. These are channels formed by the melting of the face and erosion along the slope. Something like the rivers on Earth. On the east side of this picture, we can see the rim of Plato crater. Plato himself may well have been full of faces, because the bottom is bleaker and more peaceful than the north. However, in this picture, we can see a large area of land collapsing through the crater wall. Formed a massive collapse zone up to 24 kilometers wide. This part of the Earth's crust was once connected to a higher plane. But then it collapsed under its own weight, eventually detach and fall into the crater. Now let's look at another crater. This is an amazing view from Apollo 15. Overlooking Aristarchus crater. Aristarchus is located northwest of the moon. Although its diameter is only 40 kilometers, but it's bright enough to be visible to the naked eye. From the perspective of the Apollo missions, we get a very wide view of the caldera. It is surrounded by more fine grooves and lava vents. There is also a small radiation system extending out in the center. From this perspective, As the shadow on the edge comes out, you can feel the depth of this crater. This complex crater has a prominent rim. However, it was found that the bulge in the center was relatively small. High-resolution perspective through the Lunar Reconnaissance Orbiter. Here we get an up-close look at Aristarchus crater and carefully observe the walls and bottom. These walls are similar in appearance to the Jack Swarm craters. But when looking down from the peak in the center of the Yulin crater, but found some significant differences. This mountain is not only smaller, they also show striped patterns, consolidated multi-layered structures hidden in the Earth's crust hundreds of meters below. The bottom of the crater may have been composed of lava and melted rock. Cracks caused by rapid cooling can be seen everywhere here, especially on the walls. Yunshikeng Bottom Interchange. It's easy to imagine that this used to be a liquid state, in a place where gray tones dominate. The colors on the moon can actually reveal a lot to us. And the region that we observed was called Montes Carpatus. There's an immediate change in contrast. In general, the darker regions on the moon suggest older matter. It also reflects the composition of the substance. The darkest area in this image is believed to be the Zen House, where the volcanic eruption took place 3 billion years ago. Faces have flowed through such valleys. The surface is also scattered with white spots. These are all relatively new small impact craters. They appear white because compared to the surrounding area, they're younger. Space weathering hasn't dimmed them yet. Unlike the Mars Reconnaissance Orbiter, the Lunar Reconnaissance Orbiter has the special ability to take photos from specific angles, as well as from above. This means that we can observe the mountains of the moon as if from a cockpit. This allows for a better sense of height and scale. However, since on Earth we rely on visual cues to determine the height or distance of objects, our sense of scale would be chaotic on the moon. For example, on Earth, we can tell from the blurring effect caused by the atmosphere that the mountains may be located dozens of kilometers away. In addition, we can also see real trees and so on. These all help us make a rough estimate of the size of the object we are seeing. But on the moon, none of this exists. No number, atmosphere, or town. Just based on this picture, can you guess how big the mountain is? What is the width of the image foreground? It will be very interesting to see your guesses in the comments. But perhaps surprisingly, the foreground of this image is about 15 kilometers in diameter. The peak is nearly 7 kilometers high. The two mountains behind are 200 kilometers apart, above 4,500 meters. Surprisingly, the way these peaks are named is not based on their size as they are on Earth. To understand the scale of these images, the best way is to use a tool released by NASA called QuickMap, in which various filters can be passed, include topographic maps to view mountains in the foreground and peaks in the background of lunar images. You will notice that most of these mountains are located at the edge or center of the crater. Almost all the mountains we see today can be found at the edge or center of the crater, including those observed in the famous Gobierne crater. When the cloud pit formed, we tend to only think of the circles they form. But the center of the Great Marble Pit usually has a bulge. Surprisingly, It's not primarily due to hydrodynamic effects on impact. Elastic rebound caused by water droplets hitting the water surface. It's a bulge in the center of the surface as it tries to reach gravitational equilibrium. Amateur telescopes can easily observe the Gobai crater on the lunar surface. Therefore, it has become one of the most frequently observed lunar features from the ground. And these mountains in the center look really spectacular. But they protrude just over a kilometer from the crater floor. Look around a little bit. Compared to the surrounding crater floor, these mountains appear to be tiny. They protrude up to 4 kilometers from the bottom of the crater. When observing this crater, you will notice that although the pelvic floor is uneven, but it's relatively flat. This is because after the massive impact that formed this 100-kilometer-wide crater, the ground is eventually made of solidified lava, continued to a new location on the moon. We arrived at the Apennine Mountains, a mountain range between 3 and 5 kilometers in height. It is located on the edge of one of the largest craters in the entire solar system, and a sea basin. These mountains stand in stark contrast to the solidified lava plains next to them. It looks really eye-catching. This ditch is somewhat similar to a canyon found on the moon. But in addition to the scenery and its fascinating scenery, here's something special. In fact, this is where the Apollo 15 mission landed in 1971. This means that we can also enjoy the mountains from a ground-based perspective. The moon landing is hidden there. The same mountains in the background. From this perspective, they seem to be very close. But remember this. Our perspective is tilted. These mountains and rocks are about 5 kilometers higher than the plane where the camera is located. They're taller than the Himalayas of Nepal and the plains of India on Earth. Astronauts also surveyed the ditch in a lunar rover. The ditch actually descends 380 meters. The existence of these grooves is somewhat mysterious, because we don't know exactly why they're there. A mainstream written believes they may have been more geologically active on the moon. Exposed or collapsed magma tunnels beneath the lunar surface. From the perspective of the Lunar Reconnaissance Orbiter, the traces of the lunar rover are still clearly visible today, because there is no wind or dust on the moon to cover up these marks. So even though the Apollo missions took place about 40 years before this picture was taken, but the first-rate details are still clear and variable. Talking about some of the highest points on the moon without volume is not complete in itself. Unfortunately, although it is extremely important, but because its body is very slow, only 3 degrees, it doesn't look that dramatic. It is located in one of the largest craters in the entire solar system. It is also the largest crater on the moon, near the Ken Basin, probably formed 4 billion years ago. In 2018, China's Chang'e 4 mission landed here. The Lunar Reconnaissance Orbiter has captured impressive images. This crater is huge, up to 2,500 kilometers wide, and there's a lot of jets piling up around it. This includes what is currently considered to be the highest point on the moon. The basin was likely formed by a low-velocity impact from an object up to 200 kilometers in diameter. Since the jets are mainly ejected in one direction, basins may exhibit acute angles. And here's the interesting thing. The lowest point on the moon is not far from the highest point. The bottom of the crater inside the basin is the lowest point. Deep to 9 to 106 meters. And the highest point is higher than Mount Everest. reaching 10,786 meters. For all curious people, these altitudes are obtained by comparing the average radius of the moon to the elevations of these points. As you can see, the lunar surface is riddled with craters. No matter where you are on the moon, you can see craters of all sizes. This suggests that the lunar surface is very old, and it has not been updated by the appearance of the landmine eruption recently. The last eruption is thought to have occurred in 1.20 billion. The lunar surface is estimated to contain more than 300,000 craters over a kilometer in diameter, and millions of smaller impact craters. As you can see now, the moon is full of so many small craters. Because it has no atmosphere, this means that almost every meteorite that flies to the moon hits the lunar surface. On Earth, most meteors burn up in the atmosphere. Imagine that, without the Earth's atmosphere, every meteor hits our surface every night. By observing the degree of erosion of the marble pit, we can roughly estimate the age of the marble pit. Smooth surface. The ones with visible edges, the ones with more rubble around them, are much older. The bright spots suggest that they are relatively new. It hasn't weathered much. But on the moon without water or air, how does weathering happen? In fact, this weathering is not caused by water or air. It was caused by tiny micrometeorite impacts and intense radiation from the sun. These factors make the outer layers of the lunar surface darker. Using LR's angle-picking camera, we're able to see up close how these impacts affect the lunar surface. The jets from the impact formed a linear pattern on the lunar surface. The finer dust is blown by a certain force and covers the surface, and the larger rocks rolled away after the impact. But not too far. Since these photos were taken on Lunar Day, the sun near the horizon casts a shadow on the surface, makes the meteorite itself less obvious, although you can still see new material along the crater. Compared to an ancient crater, and here you can see a much smoother one. Darker craters, although still brighter than the surrounding weathered surface of the beads. When zooming in, and you can see that some of these jets were actually ejected from another impact event in the image wall. Here's a huge rock that landed on the crater wall and rolled halfway. The Lunar Reconnaissance Orbiter can not only scan the lunar surface, you can also take more photos of relatives. This undoubtedly helps us better appreciate the depth of the moon. Observe this crater, which is about 21 kilometers in diameter. You can see some fascinating details around. Again, we see the marks left by the huge rocks rolling down the slope. And very bright walls, suggesting that this is a relatively young crater. But the matter at the bottom is darker. The contrast is very vivid. Some parts may be liquid at some point in time. The impact would initially melt the rock into lava. Lava then flows to the bottom, where the city gathers and finally solidifies. It could be up to 2 kilometers since the impact. Hit the moon at 10 times the speed of a bullet. It did have a huge impact. Another striking image shows a crater about 10 kilometers wide. What makes it special is its interesting raised edges. This is because the rock melted due to the impact, and then it slopes out and flows down and solidifies again. If we take a closer look around the crater, you can also see the spray scattered over the surface. Those jets disturbed the ground and left brighter spots. Once you know what you are looking for, even the surface of the moon can become very fascinating. What if a meteor landed in a less typical location? Here is another impact inside a crater. It hit the wall of a larger crater, formed a rather unusual shape. Although from a top view, he still looks round. This image is a true color image of the moon. Although most other lunar images were shot in black and white to save framing. Astronomers typically prefer resolution to color. Although the lowest resolution cameras on the LRO have the ability to capture color images, there are still some anomalies on the moon, such as the cold spots found on the lunar surface after the sun sets. So far, our main concern is the camera on the LR object, but it's also equipped with other instruments. Includes instruments capable of mapping the temperature of the lunar surface. When the sun sets, about 2,000 cold spots found on the moon will be cooler than their surroundings. When the sun rises again, temperatures in these places will return to normal. It blends in very quickly. The only common feature of these cold spots is they are always located around young craters between 50 meters and 2.3 kilometers in diameter. But the cold spots themselves are much larger than the crater itself. And as you can see, in the large area around young crater, rain appears cooler in terms of temperature. Scientists are currently studying the cause of this phenomenon. Moving on to one of the coldest places in the solar system. A crater near the south pole of the moon. This crater is almost always in shadow, because the sun will never rise above the horizon. Only the highest peaks of the crater are illuminated by sunlight. A stunning visual contrast. It's almost like a yin-yang symbol. This area is not only beautiful, and it's one of the potential landing areas for future Artemis missions. The lunar South Pole is crucial for future human exploration missions, because millions of tons of sailors were found at the bottom of these craters that would never come under direct sunlight. This is of great significance for establishing a base on the moon. The images captured by LRO are not only beautiful, it has also provided tremendous assistance to our understanding of the formation and geological history of the moon, like the monster Suzang Gamma. A dome-shaped structure looks unremarkable in one image, but it actually reveals the complexity of the moon's geology. The western side of the dome is brightened by direct sunlight. The east side is in shadow because of its lower elevation. Shows the depth and contrast of shadows on the moon. And to the east of the dome is his shadow. Highlights his height and slope. The dome rises about 1,500 meters above the surface of the moon. It's about 20 kilometers in diameter. Huge size, darker around. The flatter terrain was formed about 4 billion years ago by basalt intermediate flows flooding the terrain. Formed the flat surface now seen. Monsko-Susan Delta is another origin. It's bigger than Gaima. The surface around the height is about 1,800 meters, about 27 kilometers in diameter. Surrounding the two domed forms is a dark basalt plain. This is part of the once vast Sea of Storms LCNS Procellaria. It covers about 10.5% of the lunar surface. It's a very apt title. because the domes look visually like islands. Grayson Dome is like Storm Sea. It is believed that the appearance is popular from ancient times. But why did they leave behind this unusual structure? Surprisingly, there may be clues to the answer on Earth. For example, Mount St. Helens, an active stratovolcano in the Pacific Northwest of the United States. Its shape is rather similar to these lunar domes. Stratified volcano by Liu Wenyan. Formation of the accumulation of silica-rich volcanic materials such as inundite and anshan rock. After these highly viscous lava erupted from the Earth's crust, will flow slowly during cooling, hardening over time into domes or cones. We speculate the Grayson Dome may also be made of silicon-rich materials. Recent observations by the Lunar Reconnaissance Orbiter using thermal imaging instruments support this theory. These domes were found to be significantly different in composition from the surrounding plains, so unlike the basalt lava of the moon, these are more viscous. Silica-rich lava slowly squeezes out like a thick syrup. Eventually, it cooled and formed the huge place in front of me. However, it is puzzling that, on Earth, layered volcanoes like Mount St. Helens are unique products of water and plate tectonics. At the junction of two plates, cold, dense ocean plates are pushed beneath lighter plates. Return to the fiery vines of Earth. This process generates magma rich in silica, such as Liu Wenyan fire yin ammonia salt, but the moon has neither liquid water nor plate tectonics. How did this silica-rich magma form? It's still a mystery. One hypothesis holds that when lunar magma nearly cooled and crystallized, the remaining liquid may be rich in silica. But this process and fractional crystallization, only a small amount of silicone grease can be produced, not enough to explain a massive structure like the top of the Grayson Garden, which is 27 kilometers long. Another model holds that the silicon material is formed in the ascent of basalt magma. This caused some of the rocks on the lunar surface to melt, formed Liu Wenyan and shadow rock. If so, the top of Grayson should be of the same age as the surrounding basalt plains. We haven't been able to determine this yet, but future research could reveal the age and composition of these mysterious structures. The most exciting thing for me is it may only take us a year to solve these mysteries. NASA plans to send commercial lunar missions and services to the region in 2025. Rover. We will explore the lunar surface and collect rock samples. Not only does it help unlock the secrets of the bottom of Grayson Park, it will also improve our overall understanding of lunar volcanism. The high-definition images captured by LR provide NASA with key information for selecting safe and suitable landings. Imagine how this mission will deepen our understanding of the moon through ground prime ministers and rock samples. Really exciting. I can't wait to see the results. Which do you think is more plausible about the Grayson Dome formation theory? I'm looking forward to hearing your opinion. As you can see, the moon's many secrets are yet to be revealed. Like this unnamed crater, which is full of microscopic craters. This crater absconded inside another larger crater, formed a very unique geological phenomenon. These craters didn't happen side by side by accident. They have highly aligned features, collectively known as Bellwing Crater. And this structure is called the Tiantian cloud pit, or the concentric cloud pit. At first, one might have thought it was the result of two impacts that were perfectly aligned. But further observations revealed a more complex picture. What if these structures were merely the result of chance collisions? Then we should see randomly distributed craters of the same magnitude on the surface of the moon. And that's not true. In fact, these simultaneous craters tend to cluster in specific areas, especially around the edges of Oceanus Procellarum. This suggests that there are other factors at play. A deeper analysis of the crater revealed, compared to other craters of similar size on the moon, these external craters should have been twice as deep as currently observed. Although some concentric craters may indeed have been caused by a double impact, but the location of most craters, the age and depth suggest that there must be other explanations. One hypothesis is that when certain impacts occur, a portion of the lunar surface is in a state of transition between solid and liquid. Its thick poison is similar to the ripples caused by the impact of cold lava or honey that spread outward. But then it stopped spreading before the ice was completely cooled and solidified. Although this explanation seems plausible, but a more general theory holds that when the moon was more geologically active, the magma is trying to come out from below and pushing up the base of these craters. This phenomenon not only explains the precursor of the crater, it also explains why concentric craters are mainly concentrated in certain regions of the moon. Although this is currently the most plausible explanation, we're still not entirely sure. As for other changes to the lunar surface, although it is generally believed that except for the occasional meteor impact, the lunar surface doesn't change much, but we do find signs of material moving on the moon. For example, at the edge of the 32-kilometer-wide Kepler Dolomite crater, we saw evidence of landslides. Deep material apparently slipped down the slope. Zoom in to see these remarkable landslides. You can see that this material originated in a fragrant canyon at the top of the crater rim. The slider is made of very tiny materials, so that individual rocks cannot be distinguished. But the largest rocks seem to have slid to the bottom of the crater. And here's the interesting thing. These sliders are mainly composed of many smaller sliders. This suggests that these landslides did not happen all at once. It is the result of accumulation over time. These landslides were most likely triggered by a tiny epidemic that crashed into the crater wall. These popular impacts and landslides caused by them made the crater rim smoother. This explains why the oldest crater on the moon looks the same as the latest one. Smoother than the crater. Massey also offers another puzzle from the crater. It's not your typical round shape. It's elongated, and there is a narrow gap through the crater floor. There are two more craters next to this crater. The ones on the left are older than the ones on the right, because he seems to have undergone more weathering. Observing the rays far from the crater can be solid. The direction of debris diffusion after impact is different from that of a circular crater. The debris has spread in 3 different directions. This further adds to the mystery of the lunar surface. The reason for this particular shape of crater is meteorites hit the lunar surface at an angle of less than 15 degrees. In this case, the meteorite appears to have broken into 3 parts before impact, caused 3 craters to form almost simultaneously. Even the seemingly older one, due to the low impact angle, Ejecta from the second crater may have directly covered the top of the previous crater. Makes it seem older than it really is. Another interesting aspect of this phenomenon is that impact melted solidification pools at the bottom of craters, and some areas seem to collapse slightly. The impact volume visible in the image flows to the left of the image. Shows a series of complex geological activities, while exploring another asymmetric crater. Although the first consideration may be due to two impacts or an impactor that split before impact, but the reality may not be so simple. And there's this solid, shadowy crater on the summit of a mountain. Looking at the topographic map confirmed that this mountain is likely the highest point in the area. He was completely destroyed by an accidental impact. Like Mount Everest being hit by a meteor, the shape of this crater is caused not only by the angle of impact, and because he hit a steep slope, although you can't tell from the beveled stones, but there is a vertical distance of 8 kilometers from the summit to the bottom of a nearby crater, spanning about 20 kilometers. On the other hand, future colonies on the moon may choose locations closer to the poles. The reason is that it is impossible to hide a large number of sailors at the bottom of the marble pit in permanent shadow. This was crucial for the colonies. Water is not just for drinking, clean cooking and agricultural use. It can also provide breathing air and rocket fuel by decomposing into oxygen and hydrogen. The added benefit of the polar regions is that certain peaks are almost always under sunlight. This contrasts with the 28-day day-night cycle elsewhere on the moon. This environment is ideal for installing solar panels to power the colony. Although this is not a perfect solution, because depending on the time of year, these mountains will eventually be covered by darkness. But 89% of the time it's exposed to sunlight. This is more powerful than the other regions on the moon that receive sunlight about 50% of the time. At the end of the exploration, we turned to the central mountain found on the far side of the moon in the Baba Marble crater. They are as unique as islands in the dark. Through the eyes of Route 62, we were able to explore the ancient and mysterious land of the moon, discovered its incredible beauty and wonder. The mission of the Lunar Reconnaissance Orbiter is to map the lunar surface in detail, providing scientists with unprecedented data and images. As he continued on his carefully choreographed trajectory, travel through different times and seasons, LRO is expected to reveal more unknown organs on the lunar surface. These could include psychological craters caused by new asteroid impacts, or rock slides caused by lunar formations. Such a launch would further demonstrate, even today, the surface of the moon is still slowly evolving and changing. When the Lunar Reconnaissance Orbiter finally completes its mission, expected to end its journey in a highly symbolic manner, a graceful fall from an orbit, its crash site will form a new small crater. Although this newly formed crater will not be as massive as the Keene Basin. But because the moon lacks an atmosphere, wind and weather changes, this crater could have persisted for thousands of years. This will become a permanent symbol. Demonstrate his tremendous contribution to mapping and understanding the lunar surface. This mission was not just a feat of scientific discovery. He is also paving the way for the future, by providing detailed data and images of the lunar surface. It will provide valuable information for those who may establish a home on the moon in the future. This detailed image of the lunar surface could help scientists and engineers better understand the moon's geological properties. For future lunar exploration missions, including long-term human habitation on the moon, providing the necessary basic knowledge